welcome all of you to another maths lesson. The formula to find the sum of first n terms of an arithmetic progression is S is equal to n by 2 into 2a plus n minus 1d. We can also write the same as S is equal to n by 2 into a plus a. If the sequence terminates, if the progression is finite, S is equal to n by 2 into a plus n. Let's start with question number 9. So I have copied the question into whiteboard so you can easily see the question here. The question is, if the sum of first 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of first n terms. Okay, so question is like this: sum of first 7 terms are given and sum of first 17 terms are also given. We want to find the sum of first n terms. That's the question. Okay. So what we do here is we make a pair of equations and then we solve the pair of equation, and then we will get the values for a and d, the first term and common difference. That means we can form the progression, and from the progression, when we get a and d, we can find the value of sum of n terms. Okay, so you can do this here. So you can start with the formula. We know the formula of sum. Sn is equal to n by 2 into 2a plus n minus 1d. 2a plus n minus 1d. Okay. So here it is given that for sum of first 7 terms is 49. So we can write as sum of first 7 terms means S7. So S7 is equal to we can apply this first. So this will be 7 by 2 into 2a plus n minus 1d. So 2a, we don't know a, so we write it 2a plus n minus 1, we write n minus 1. So n we know, right? So we can put, so n minus 1 we can write as 7 minus 1 d. Okay, d we don't know the common difference. Okay, we know the answer. This is equal to 49. This is equal to 49. So in next step we can start from here. Okay, so 7 by 2 we can write the same, 7 by 2 into 2a plus 7 minus 1d. So we can write 2a plus 7 minus 1 is 6, so 6d is equal to 49. Okay, in next step, inside bracket you can see both terms are multiples of 2. So you can take 2 common outside. Okay, so 7 by 2 into 2 you can take outside from the bracket. So if you take 2 from 2a, it will remain a only. Then plus, if you take 2 from 6d, it will remain 3d. Okay, so it's equal to 49. Now you can cancel this 2 and 2, and you can move the into 7 to right side. So you will get a plus 3d is equal to 49 by 7. Yes, 49 by 7. So a plus 3d is equal to what? A plus 3d is equal to 49 by 7 is 7. Okay, so we go to one equation. We give name equation number 1. From the second sum, it is given that sum of 17 terms is 289. We can make another equation, right? Can you try now? You do S17. So second sum is given that 289. You can do similar steps. You will reach in an equation having a and d. S17 is equal to 7 by 2, not 17 by 2. N by 2 means 17 by 2. 17 by 2 into 2a plus n minus 1d. So 2a, we can write 2a itself. Then n minus 1, n is 17. So n minus 1 is 16, right? So 16d. Okay, n minus 1d means 16d. Okay. And this is given that 289. So in next step we can write a 17 by 2 into, you can take 2 common outside the bracket. Okay, so into 2 and inside bracket a plus, if you take 2 from 16, it will become 8d. Okay, it's equal to 289. And next step, you can cancel 2s and you can move 17 to right side. So a plus 8d is equal to 289 by 17. So you know 289 is the square of 17. So if you divide 289 by 17, you will get again 17. So a plus 8d is equal to 17 itself. This is the equation number 2. So a plus 8d is equal to 17. And so we got two equations. So we can solve for a and d by combining these two equations. So you can do 2 minus 1. I think 2 minus 1 is better here. So equation number 2 minus equation number 1 gives you what? So equation number 2 minus equation number 1. A and A will be cancelled. And 8d minus 3d, what will get? 5d, right? 5d is equal to 17 minus 7, you will get to 10. Yeah, so 5d is equal to 10. So d is equal to 10 by 5, and that is equal to 2. So we got the common difference. Yes, we got the common difference of this arithmetic progression. So now we can substitute this value of d is equal to 2 in equation number 1 or 2 to get the value of a. So here I substitute d is equal to 2 in equation number 1. So 1 becomes what? A plus 3d means 3 into 2, d is 2. A plus 3 into 2 is equal to 7. So in next step, I write next step here. So in next step, it will become a plus 6 is equal to 7. So next step, a is equal to 7 minus 6, that is equal to 1. So we got a and d. Okay. Now we can read the question again. The question is, find the sum of first n terms. Find the sum of first n terms. So what we have to do is, we want to substitute the values of a and d in this formula of sum. So we can reduce the formula in terms of n. Okay. So look here, the sum Sn will be, we know Sn is equal to n by 2 into 2a plus n minus 1d. 2a plus n minus 1d. And here we substitute the values of a and d. Okay. So here you will get n by 2 into 2a. 2a means here a is 1. So 2 into 1, right? So 2 into 1 plus n minus 1 times d. And d is what? D is 2. So we write it 2 here. Okay. And in next step, here 2 is common. So you can take outside the bracket. So n by 2 into 2 we take outside the bracket, and inside bracket it will be 1 plus n minus 1. Okay, so here 2 and 2 you can cancel, and plus 1 and minus 1 you can cancel. So what remains? N into inside bracket another n. So n into n gives you n square. So Sn is equal to n square is the sum of n terms of this arithmetic progression. Sn is equal to n square. Okay, so I shall repeat again. So here the question is, sum of first 7 terms of an arithmetic progression is 49 and 17 terms is 289. We want to find the sum of n terms. So we cannot get the answer in numbers because the sum of n terms given the algebra only, n terms. So answer will be in terms of n. Okay. So how we did? We know the formula to find sum. So we applied the formula in S7 and S17. So we got two equations in A and D. We solved this pair of equation, and we got A is equal to 1 and D is equal to 2. We substituted these values in Sn. So the formula reduced to Sn is equal to n square. For this particular arithmetic progression, to get the sum of first n terms, we need only to square the position number. Okay. So in yesterday we have discussed the an in terms of n, and I told the an will be always a first degree equation in n. For an example, like bn plus c or something. Okay, the an, the general term of an arithmetic progression, if you substitute the value of a and d, it will be like a first degree equation in n. But the sum, if you put the values of a and d in our formula, you can reduce into a second degree equation in n.